Welcome to homework.
In this problem, we're given an initial speed of 3 meters per second and an angle of 25 degrees, and a crate is going up a ramp. And so we want to know how far it goes up the ramp. And so as it goes up the ramp, it's going to start slowing down. So we're going to start with the sum of the forces in the x direction, which is parallel to the ramp. So in this case, we're going to have a component of the force of gravity that goes down the ramp in the same direction as friction. So we'll say that negative mg sine theta, we're going to call up the ramp positive. So negative mg sine theta minus friction equals ma. Again, friction here is the coefficient of friction times my normal force, which in this case, my normal force is equal to the perpendicular component of gravity. So negative mg sine theta minus the coefficient of friction times mg cosine theta equals ma. Masses cancel out. And so I have negative 9.8 times the sine of 25 minus the coefficient of friction, which was given to us as 0.17. 17 times 9.8 times cosine theta gives us an acceleration of negative 5.6, which makes sense because it's slowing down as it goes up the ramp. And then we can use a kinematic equation to solve for the distance that it traveled up the ramp. So we're going to say it goes up the ramp until it stops, so my final velocity of 0. And we're given an initial velocity of 3 meters per second. Gives us a distance up the ramp of 0.796 meters. For part B, we want to know the total distance that it traveled before it returns to its initial position. So the time it takes to go up the ramp can be calculated using another kinematic equation. Again, final velocity of 0, initial velocity of 3, gives me a time up the ramp of 0.53 seconds. Now we need to calculate the total time down the ramp. For this, we do need to recalculate our acceleration because our acceleration is different now as it comes down the ramp. So as it comes down the ramp, I still have a component of gravity going down the ramp, but now my direction of friction has changed. So I have a new equation. Okay, now my friction and my mg sine theta are in opposite directions. My masses cancel out, and my new acceleration is going to give me a positive 2.63 meters per second squared. And I already know the distance that it traveled up the ramp. That's the same distance it's going to travel down the ramp. So 0.796 is the distance it'll travel. So I can use a different kinematic equation to find the time it takes down the ramp. Now in this case, my initial velocity is not 3. My initial velocity as it comes down the ramp will be 0 meters per second. So this gives me a time of 0.77 seconds down the ramp. If we add that to the time we took to go up the ramp, we get a total time of 1.3 seconds.